Okay, now uh, cross product of two vectors. We know that two vectors can be multiplied via cross product and represented like this. A vector times A vector cross B vector is equal to the magnitude of vector A times magnitude of B times sine of the angle between these two vectors. And this unit vector n is the unit vector in the direction of perpendicular to both A and B. Okay, now let us consider we have two vectors like this, which are represented in the form of the coordinates. Like A is represented by AXI plus AYJ plus AZK, and B is represented as BXI, BY plus BYJ plus BZK. So these X, Y, and Z are the components along X axis, Y axis, and Z axis. Now let's multiply them by cross product. We write them like this, and then we multiply them the usual way we do our multiplication of two brackets. Just like that, there is nothing special going on here. The special thing that we need to pay attention to comes in this last step here. So we separate our vectors, which are unit vectors in this case, and our scalar quantities uh, on the outside of the bracket. So the purpose of this is doing this is to make it easy for ourselves to see where and which unit vectors are being multiplied via cross product. Now first we take a look at how unit vectors are multiplied via cross product, and then okay, we will use the same expression for cross product of unit vectors. Let's take cross product between I with itself. So the cross product of I with itself will be like I cross I. It will be equal to the magnitude of I times magnitude of second I, then sine of the angle between these two. So the angle between these two is 0 because both of them are pointing towards x in the same direction, so the angle will be 0. You can write like this. So the whole expression, so okay, and sine of 0 is, we know that it is equal to 0, so it will make the whole expression equal to 0. Therefore the cross product of I cross I is equal to 0, or in other words you can say that the cross product of same vectors, or the cross product of a vector with itself, will be equal to 0, because the angle between them is 0 and sine of 0 is 0. It makes the expression equal to 0. Now let's find cross product between I and j, two orthogonal unit vectors, or the unit vectors which are perpendicular to each other. Same thing, the magnitude of I is 1, magnitude of j is also 1, but the angle theta between I and j is 90 degrees from here. So we write like this: sine of 90 is equal to 1, and n, it should be in the direction of k. How? So in cross product, the method of finding out direction is using right hand rule. In right hand rule, we curl the fingers of our right hand from first vector to the second vector, means from I towards j. If we do so, when we curl our fingers from of the right hand from I towards j, the thumb will be pointing outward from the screen, which is the direction of k. Therefore we can replace n with k like this, and our cross product between I cross j becomes equal to k. Now let's find the cross product between I and k. Okay, same thing. Here the magnitude of I is 1, magnitude of k is also 1, and the angle between them is 90 degrees. So we can write like this. So we know that sine 90 is equal to 1, but what is the direction of n? The direction of n we will find in the similar way as we found for I cross j. So we have to curl our fingers of the right hand from I towards k. This is I and this is k. We have to realign our hand so that we can curl our fingers from I towards k. When we do so, you will notice that your extended thumb will be pointing towards downward direction. So that is the direction which is opposite to j. Therefore, we can say that this is equal to minus j. It is in the direction opposite to j. So opposite to j is minus j. So I cross k is equal to minus j. So similarly, we can also prove that j cross j, same vectors, means the cross product between same vectors, and k cross k is also the cross product between same vectors. It is equal to 0 because sine of 0 is 0, and both of them makes angle 0 between each other. Like here, I cross I is equal to 0, that's why j cross j is 0, and k cross k is also equal to 0. But in order to find these, it is very simple. We use this counterclockwise wheel. So we mention each unit vector against each wheel, but in the counterclockwise direction. We take cross product between I and j, we get k. We cross product between j and k, we get I. We take cross product between k and I, we get j. But when you go opposite or in clockwise direction, means from j to I, means j cross I, we get negative k. So I cross k, we get negative j, and k cross j we get negative I. That's how we can find our positive and negative answers are in the cross product. But it is very simple. We cross product 2, we get third vector. But what is the sign with it? That depends on in which direction we are multiplying, in which direction we are taking cross product. We are taking it in counterclockwise or clockwise direction. Okay, now let's go back to our cross product of A and B. So for reference, I have written all of these here. Okay, now this was our last expression that we left in the previous slide. Okay, in this, the cross product between similar vectors will be 0. These red terms will become 0. I cross I, j cross j, and k cross k, these are 0. So after inserting these values, we get this. Here I cross j is k, I cross k is minus j, j cross I is minus k, and j cross k is minus I, and like that. So after rearranging them, we get this. So in this, you will see that some quantities are with same unit vectors like k and k, j, and j, I, and I. So we can write this expression like this. We take unit vectors out and scalar quantities in the bracket. Now it is it can be very useful for us, but we can also find same expression, this one, the red encircled one, by determinant method. Okay, now let's take a look at our cross product via determinant method. This is very simple. The way to write it in determinant form is like this. We're taking cross product between A and B. So the first row is the unit vectors I, j, and k. The second row are the components or the coordinates of vector A, and third are the coordinates of vector B. So first row unit vectors, second row coordinates of vector A, and third row coordinates of vector B. Now we need to expand it. We need to find out its determinant. It is also very simple. You just need to focus that how we do it. There is a set way of doing it. So first, in general, we start on the we take the first row, okay, and the first element of that is I. So we write I here and block off the first column and first row and first column. we are left with this. Then we multiply them diagonally, starting from left top to bottom right, and then from bottom left to top right, then with a negative sign between them. So ay bz minus by az, we write like this here. Now next we move to the second element of the first row like this. Now this j is in the second column, so we block off top row and the second column. We are left with these terms. Now we write j first and then we multiply diagonally like this. Ax times bz minus bx times az like this. Now we move to the third element of the first row. We have to block off the third column because k is in the third column and the first row. The rest of the elements will be multiplied. So ax by minus bx ay like this. But what about the signs between them? What mathematical signs we will put in between? It is also simple. We start with positive, then change to negative, and then positive again like this. So first is positive, then negative, then positive again. So for the first expression, the first term, we will add positive sign, this one here, with the second one negative, and with third one positive again like this. So in this way we get the similar expression that we got in our previous slide. So you can use whichever way uh, you feel easier to do or quicker, or whichever you understand better. Okay, now let's do a example. In this example we have same vectors as we had in the previous example of a dot b. We're using same two vectors for finding out the cross product by determinant method. So first row will be I, j and k, and the second row will be the coordinates of vector a, 3 and minus 4 and 0 because it does not have the third or the coordinate along z-axis. So 3 minus 4 and 0. And for the third row are the coordinates of vector b. So vector b's coordinates are 2 I plus 0 because it does not have j or y component, and then minus 3 like this. Now we find out the determinant of this a cross b like this. So we will do the same thing. Take first I and block off the top row and the first column, and then multiply these two, minus 4 times minus 3, and then minus 0 times 0. So exactly in the same way that we did in the previous slide, and our answer is this this vector 12i plus 12j minus 8k.